Welcome everybody for this talk on unlocking the secrets of the Devoxx mobile app, deep dive into open source PWA with Vue and Firebase. I was supposed to do the talk with Frederick Kambler, but he's not here, unfortunately. Do you enjoy the conference so far? Is it okay for you? It's a super great conference. There is a talk yesterday that was very remarkable, I think, the talk about the imposter. This is exactly what I feel today, like an imposter. Because this is mostly Java conference with many things about artificial intelligence, but in this talk we'll see no Java, no artificial intelligence. Maybe you could think it would talk about Vue.ai, but no, you won't see any Vue.ai in this talk. So maybe you would expect to have the developer of the app in front of you, the main developer, but no, I'm not the main developer of the app. And even the talk summary and the talk title, I didn't write them, actually. It was Stefan here who wrote the talk title and talk summary. So I'm definitely an imposter for the talk, but still, as Don said yesterday, you cannot be an expert in everything, so it's fine to be an imposter. So let's start this talk. And welcome, everybody. We'll use some AI in the talk, because we have, I had nothing to say about Java and AI by itself, so I just use AI for the images, for some images. You see this is a deep AI image. There is the small sentence saying what I asked Deep AI to generate this photo. So welcome people at Devoxx conference, and this is what I got. And yesterday I saw a talk about Firefly, so I thought I could also use Firefly to generate the photo. So welcome to this talk. This is me. Depicted by Firefly. I'm a Java developer since Java 1.1 or Java 1.0, I don't remember, 1996. It's been a long time. I've been the creator of Apache Ivy for the long people working for a long time. Maybe you knew that. Anybody know Apache Ivy in the room? Oh, a few hands, 10%. Well, so I've committed this crime a long time ago. And I'm also the creator of RESTX, which is a small open source framework for REST development, but it's not maintained anymore and not used very widely. I also attended Java Police 2006. The first time it was really enormous to be there, and so I'm very, very, very happy to be there 17 years after that. And this is me for Deep AI, a slightly different face, as you see. I'm a code addict. I currently code in Kotlin, mostly. I'm the co-CEO of Firestore, which is a French company, French consulting company, with around 100 people, based in Paris, Bordeaux, and Cabreton, in Les Landes. It's very beautiful with waves and beaches and nice. I'm the father of two wonderful kids. I hope they will watch this talk, and so that I can just say them that I love you, Jules and Mel. A bit about the story of the Devoxx app. It all started with Stefan meeting Frederick Kambler, who is not here. So you can see them there. Well, and the AI generated that. And this is the email that Stefan sent. Hey, Frederick, Xavier, would Wednesday, 19 April morning work for you guys to have a Voxxrin Devoxx mobile Hangout discussion? So it all started with that discussion. And why did Stefan ask Frederick about that? This is because a long time ago, we developed a first version of a conference component app called Voxxrin 1, which was I developed that version. It was in 2012. That later Frederick Kambler did development of that. It was developed in jQuery Mobile. We won't talk about that. And then a later version was Voxxrin 2, developed by Elian Oriou and Romain Lopez, who both work at 4SH. It was developed in 2016. you see the look is very different. Robin did a very good job on the UI working. And then Voxxrin 3 is the version that you use today to get the Devoxx mobile version of the schedule. This version has been developed by Frédéric Ambler and Robin Lopez. I did very, very little help. Also Vincent Marquez and Forest helped also a little bit. This version of Voxxrin is open source, so you get the link over there, github.com, Voxxrin 3, with a brand new look and code base. Everything is new. There is nothing from the old versions inside. It has been started in April, and it's intended to be to have a white label version. So you can customize it for different brands, and it has been customized for Devoxx, where you get all the Devoxx-related events. And thanks a ton again, Stefan, to give us the opportunity to do that. Okay, maybe we can start with a demo. Usually we end with a demo, but I decided to start with a demo. You already know the app. Do everybody have the app on his phone? Yeah? Almost everybody? Okay, we'll use it during the conference. So you already know this app where you can get the different events, get on the event, okay? We can use offline. If I switch off my Wi-Fi, I hope I will get it back after. I can still browse on the schedule like that, and I can get the details while I'm offline. So you have already experienced that. If I get back the Wi-Fi and if it works properly, hope so. We should also see that with my talk. Well, okay, I will just search for it. Xavier. Okay. I am. So the current count of favorites over here is 172. Maybe we can try something together. If you can go on the app and go on the talk, and if you have the favorite on the talk, maybe I guess that some of you have the favorite, can you just remove the favorite? All people having the favorite can just remove your favorite just to see the count over here, which is updating in real time. I'll just give you a few minutes to remove the favorite, and then I will ask everybody in the room just to put a favorite, just to see if we can go higher than where we were before. You can remove it afterwards, just for the sake of the demo. Okay, so you see we've got real-time update like that for the favorite count. And we also got a real-time update if you go on the details of the talk. If you just hit the talk and go on the details and you switch and look at the speaker, this is me. You just look at that right now, and I will update it in the database here and just say an imposter. Here, I update, and you should all see all together the update. Xavier, an imposter. Do you get it? Yes. Yeah? It works. Well, great. Good job, Frederick. I will remove that because, well, I'm an imposter, but I don't want everybody to know. Okay, so this was for the demonstration. But we are at a technical conference, so I guess that you don't just want to see demos and you want to know about technical stuff on this app. So we'll start diving into the mobile part. This is the part I'm the less comfortable with. Frederick was supposed to talk about that, but he's not here. So on the mobile, we use Vue 3 with the TypeScript. for the framework, we use Ionic and Capacitor and Firebase SDK. I will show you some code about that. Just here, okay. Is it big enough? Yeah, big screens should be big enough. So I just launch, as usual, when you do front development with such tools like Vue and etc., you can just npm run something. So I npm run dev. I've got here a link that I can open to do my local development. Here I'm connected to a demo database, so I'm not directly on the production database, but I can do the same things than on the production data. Just have to fill the data because right now. Here you've got on a Vue component. How many of you are already comfortable with Vue? 20%. So Vue is a framework, a front-end framework that can be compared with Angular, React. It is kind of in between because you can have really a component approach like in Angular, or you can have an approach more like in React with composite with reactive functions. Here it's the style of which is closer to Angular. So you've got, when you have a Vue component, you've got here a part of the component is a template. So you can use regular HTML inside. Here we have Ion button, Ion icon, and so on, because we use Ionic. Ionic is a framework which is used to provide components, web components, which are intended to be used on mobile. And this is what helps, for instance, to get a very good performance on the list. If you browse the list, when you scroll on the list, the schedule list like that, on mobile, sometimes it's not very fast, and the list is optimized for mobile by using Ionic for that. But we use it for all the components. So here we've got an Ion button. This is talk favorite buttons. So this is the button behind. Just am I on the good? Yeah. Looking. Yes, over here. So this is the button for that. If I just sorry, it's just a bit flaky. Okay, so this is this button that we've got here, and so we have Ionic button, and inside we've got an icon which is shown only if it's favorite or not. This is what is used. Oh, sorry, I click on the misclick. My trackpad is lost. Sorry for that. I don't manage to zoom out. Yeah, okay. So this. The color beneath and the icon is changing when it's a favorite based on that. And you've got a label with total favorite counts, which here with the demo version is 100. So for instance, I can just add a few to get a better feeling about myself, but also others. Over here. Then you've got a script section. In the script section, you can define properties, and well, it's really behaving strangely. You can do your TypeScript code over here, and then you've got the styles, and here I'm just relying on the Robin to do all the styles. So this is it for the Vue Ionic, and also I told that we are using Capacitor. Capacitor is a framework which is used to package a web app as mobile application. You can package it as a progressive web application, PWA, so difficult for me to pronounce. So this is a version that you are using on mobile.devoxx.com. If you install the app, you get this little icon on desktop too to install the app for the progressive web application. But it was also intended to be used directly as package application. So you can use here it's Android Studio, and with Capacitor, you just have a command to run the application in Android, and you get the packaging of the Android app. You don't have to know Android at all. Neither do you have to know iOS at all. You can just use Ionic, and with Capacitor, it will just package everything for you, so that you don't have to know that. And this is the exact same app over here. This is an emulator of Pixel 6a. So I can use the app inside the emulator right here. And it's just the exact same version package here. This is useful, especially when you want to test native stuff. We don't have much, we don't have any native components yet in the app, but it can come, especially for the notifications. We intended to have notifications about the tools. When you have favorited something to tell you, don't forget to go there, and don't forget to give your feedback, and so on. So this is for the notifications. We need to access the native version. This is intended to be used. Okay, so this was a part on the mobile. I did already, yeah. This small demo. Now let's go to the server part, backend. The server part is the serverless, so maybe I can just stop talking. No. Serverless, we still have things which are run on the server. We use Google Cloud with Firebase, Firestore, and Cloud Functions. All the development is done in TypeScript, so we use the same language on the front and on the back. One core thing that we use of Firebase is called Firestore. How many of you already know and are comfortable with Firestore? A few of you? Okay. So for the others, Firestore is a document-oriented database, which has several properties. It has real-time and offline support out of the box. I will really go into that later. It has massive scale. You can put really very large amount of documents. That's not the use case that we have here. We have only a few documents inside, but really Firestore, you can use it with a tremendous amount of documents. And it has a web console like that, where you can edit your document, view your documents, do some queries, and so on. You don't have to have your tool on your side. You can just use the web console that I showed when I demonstrated the push, the real-time update of my name. So the first thing to see when you use Firestore is how to organize your data inside. So I said it's a document-oriented database. So we need to store documents. Documents are JSON-like data structures. So you can store in a document a pretty large amount of data. You structure it like you want, and you need to organize your documents in collections. If you know other document-oriented database, this is very usual to have collections to organize your documents. So here we have a collection called events. In this collection events, we've got a document ID here, the DVBE23. So this is a document which describes the conference Devoxx Belgium 2023, where we have some basic information about the conference. And then we can organize Firestore using sub-collections. This is not always the case. In other document-oriented database like MongoDB, for instance, you don't get that feature of sub-collections. So a sub-collection is a collection. It's a kind of collection embedded in the document. It's not really like that it's implemented, but you can see it like that. So we can have a sub-collection called days in the document DVB23 and have a document here called Wednesday in the sub-collection of days. And in this document, we've got the whole schedule of Wednesday of the conference. We get all the talk title, all the time slots, and so on. So this is how the data is organized in Firestore. What is interesting, it's because we use a document-oriented database which supports JSON-like data structures, and because we use TypeScript on the front and on the back, we can share the data structures that represent the types we have in the documents. So we have direct expression. This is TypeScript type definitions. So we can export types like that. So we have in the document describing the schedule of one day, we've got daily schedule with the day itself, which is just a string. Then we've got time slots. Here, when we describe one day, we have time slots. Each time slot by itself can be either a break time slot or talks time slot. And then if it's a break, it extends a time slot base, which has a start and an end. And it has information about the break itself with the title and the kind of break and so on. And if it's talks time slot, you have an array of talk. And the talk itself is described with the speaker information, talk format, and so on. And you get the information in the talk that you get that we need to display the card showing the basic information about the talk, except that we don't put the statistics like the favorites counter in this document to have it refreshed in a separate document. And we also get a subclass of talk, a detailed talk, which is used to add additional information when we need to add the details of the talk. So this is stored in a separate document and in a separate type. The operations on Firestore are very easy. You can use with TypeScript, you can just say I go in the collection, in the events collection. I reference a document by its ID, the document event.id in this instance, and then I can just set the document content. This is very, very easy. When you've got a TypeScript or JavaScript object, you just set your JavaScript and it will be stored in your document, in your Firestore. And when you want to query your database, it's very easy also. You just access your collection. It's a different collection here, crawlers, and you can use a where. The where has a dedicated API to do your where, so you need to learn that, but it's pretty easy to do. And then you can get the result within a wait because it's all based on promise. And always we have a web console. So this is the basics. And now we'll see how we use Firestore to get the offline support. Offline support, one thing important, because Firestore has out-of-the-box offline support. But if you just try to bring offline to an existing app, if you have an app and you think about your app like a regular app and want to bring offline support afterward, this is very difficult to get it working correctly. And even when you think about it first, it's also difficult. So you need to think offline first. You need to design your app for offline. And the way to do that is not that difficult. You will need to think database and not think API. For instance, for the daily schedule, in a regular app design, the app I've developed tons of time before, we think about an API. We just say, to get the content of this screen, I will do a get on a server somewhere. An HTTP get if I use a REST API to get my schedule, and then I can get also other information. So this is what we do usually. And if you use this approach and want to bring offline support afterward, you will need to think about different way to cache the result of the get. You can use service workers for that. You can use your own custom way to do that. But it's pretty difficult to get it working properly because you always need to deal with your cache manually. If you use Firestore for offline, you can just say, OK, you design that as if the data is already available in a local database. So you just access your Firestore database on your mobile, on the front end, on the web front end. Just access it like that, and that's it. You get the approach, and Firestore will do the heavy lifting for you. So this is the approach that you use for loading data. On the mobile, in TypeScript, you query a document in a local database, and Firestore will do the heavy lifting for you to bring the data inside your local database. So you don't have to worry about that. You don't have to say, when do I want to sync? And Firestore is handling that for you. So this is very easy. Now, when you want to make an update, it's the same problem. With an update, in a regular app design, you use a put. You put something with or post HTTP. This is very regular design. In this case, when you are offline, what do? You can queue your put and get a list of commands and so on. This is difficult. If you use Firestore, you can just think database, and so you just need to update the document in your database and trust Firestore to make the sync afterward. So updating data, your TypeScript code will you just call update something like we have a document which represents the notes that you take. It's called notes because it was supposed to be able to also take some commentaries or something on the talks. Which is not supported at the moment. At the moment, the only note that you have is a favorite or not. This is called a talk note. So we store a talk note document in the database, and then, in turn, Firestore will sync this update with the Firestore database on the cloud. So we don't have to think about that. We just think about updating a local database, and that's it. Well, that's it, but what about business rules? If I say that I've just designed my application as if it was a local application with a local database, this is fine when you think about just an application which is used on for one user. But when you want to deal with several users, you need to deal with business rules, and sometimes it's not that easy to design that for offline. In regular app design, usually you've got all your business rules on the server. If you design for offline, well, it depends. The first thing that you need to answer is the business rule required for offline? Is it required to have the business rule applied when you are offline? If the answer is no, then you can just use code on the server, and here we will use Cloud Functions and Firestore triggers. If the business rule is required when you are offline, then you can ask, is it something where I can trust the client or not? Trusting the client is saying, if the business rule is limited enough to say, anyway, the user is able to modify also the other. If you have a business rule saying, if I modify A, then I need to modify B. If the user is anyway able to modify B, so maybe it's OK to just say the client will propagate the change on A on B. or maybe it's just not business rule, but more an UI rule or something like that. If you can't trust the client and require it to be working offline, then it's more difficult because you will need to apply the business rule on the client if you are offline. And then when you are going back online, you will get a synchronization with the server. And when the server is synchronized, you will need it to update and not trust what the client did. So you will need to implement the business rule twice, except if you use shared code, which is the proper recommendation in that case, if you can do it. So in this case, because we use TypeScript on the server and on the front end, we can reuse and we use shared data types between the server and the front end. So we can use shared code in this case to have the business rule applied on the client, but then when the server receives the information, it applies and verifies the business rule. Here is an example of a business rule, a very simple business rule about the favorites counter. Designing for offline, the favorites counter is not so easy to implement because you could just say, I will query all the documents, all the users who have favorited this talk. But this is something that we do not want you to have on your mobile device, the list of all the people having favorited a talk. So on the local, on your mobile app, we cannot use a query on the list of users having favorited. So we need to have a document somewhere where we store the information of the number of favorites that you have on the talk. And this is a document that is public and can be shared with your mobile. So we have this document called talk statistics, talk stats, and we need to update that document on the server. For the offline app design here, the answer to is it required offline, we said no. It's okay to, if you favorite a talk when you are offline, it won't increment the total number of talks of favorites on the talk. If you can try it if you want, you just go offline and you put your favorite or not, it will just change the color, but the counter won't change because the counter is updated only when you are online. So here is how it goes. When a user updates the talk notes document, so say toggle favorite, this is a favorite or not, I just update, okay, and then on the cloud, Firestore, you have support for triggers. If you have used almost any database, is supporting triggers for years. When I was doing a record database a very long time ago, it supported triggers. And all databases still support triggers. So you use this paradigm of trigger. So you can register on Firestore to say, whenever a document changes, I want to do something. And what you do is a cloud function. It's calling a function which is on the cloud and hosted by Firebase. And so you don't have to deal about where it is deployed. You just say to Firebase, this is a cloud function that I want you to call when the document is updated. Then in this function, which is developed in TypeScript also, we just update another document, which is called talk stats. And we count. Here we can count. Well, we do not count because if we counted, we would have a transaction issue because when many people are changing their favorites together, it would be a bit difficult to count every time. So we just increment or decrement. So here is how it is implemented. We have this function, which we call on-user talks note update. So we just access functions Firestore. On the Firestore, we reference a document path, but this is not the path of one document. This is a path with parameters. Here I see that I have the user ID, event ID, and talk notes. So this is the organization of your Firestore. So with a collection users, with a user ID for a document, a subcollection events with an event and talk notes and day. And then we have this onUpdate function that the lambda passed here will be called each time there is a document update. So we just register for that. And then we can get the parameters. Here you see we have a change in context. In the context, we'll get these 3 parameters. And in the change, we'll get the old document and the new document. So we just put that in different variables with the before and after. And you see, we can just take the data of the before, and as user data knows, we use our type because it's just JavaScript. So this is very simple to get the document as an object. Then we go about all, because in one document you can have several favorites. So we just go over all of them. We check if the document was a favorite or not before, based on the before document. So we just check if it was favorite before, is it favorite now? And if it is different, if you toggle your favorite, then we just log something and push in this array a promise to update the toggle stats collection here with the field value increment. This is where we say we will increment the field with +1 or -1. And then this promises array is returned by this function. And that's all for this kind of business rule. This is pretty easy. Another thing that we need to face when we deal with offline and dealing with a local database is security. If you have a local database, I said that everything is in sync, but you cannot have your whole database in sync with your client. And sometimes you don't want. There are things that you don't want to synchronize on your local database. So obviously, Firestore has integrated security. It is based on Firestore security rules. You have a small file where you define that. You can just say, I will match on several documents. You can create a function. Here we created a function which is very simple to say, I am user ID. I am user ID if the request is not null, request as an hot and user ID, and then this is me. Then we have a rule saying that by default, we prevent read and writes on any document like that. And then we have a document representing a user. And for that document, we say that we allow the way to write that is a bit strange because you say allow if false. So it's disallow to list, create, and delete. So locally, people won't be able to list other users or create user or delete user. And you allow get if I am user ID. Here is where we use the function. And then we can get subdocuments and rules for the subdocuments. A way to do this is very limited. You can just say, I can do something if I am the user that I have identified. So when you need something else, one way to address it is to use unguessable secret tokens. So you can just have documents where you do not allow to list the document. You only allow to get it. And to get it, you will need is secret. It's a document ID. And the document ID is the public secret token, a secret token that will be shared with a user who has access to the document only. And in this case, somebody with bad intentions won't be able to get it unless he's trying to brute force the application, trying all tokens that could be guessed. But the idea is to make it unguessable, so very, very long and unguessable. Is that it for offline? And is it working correctly? On the mobile app, everything is not based on Firestore for offline. It's a progressive web application, so all the assets, the JavaScript files and images and so on, everything is handled by service workers. So we need to define with the service worker when things are updated. And you get pretty frequently a reload button on the app. This is something that we would like to avoid, but this is due to the PWA. With a mobile native app, we wouldn't have that because it's really related to service workers. And we also have issues with flaky connections when the connection is good, bad, not there, and so on. So Frederick attempted to work around the issues with flaky connections that he experienced before, and he tried to do that with a cache over Firestore. So we have Firestore, and there is a cache over Firestore. It was really difficult to test. We discussed that together. I'm not sure if it's really completely a good idea. I don't know, because I know that several people had issues with flaky connections. And sometimes we get the infamous blank screen. Sorry for that. We really need to check how to get rid of that. Real time. The good thing is that we just designed our application for offline, and we get real time almost for free. This is all the things I already shown to get an update. When somebody updates favorite, it goes to the database, it updates the toggle stats, and then when the toggle stats are updated, we've got the Firestore DB syncing, heavy lifting, which is pushing the update to your mobile. And once it's there in the mobile on your local database, you get an update just by subscribing on the database, on the local database, on the mobile. We subscribe with a function which is called onSnapshot. We just subscribe with it, and we get an update. So this is very, very easy. This is the magic function of the Firestore SDK on mobile. This is a web SDK, which is allowing us to do that. On all front-end platforms, the Firestore SDK is allowing to do on snapshot, not on the back-end, on the cloud functions. You can do that. It's different. But here we can query a document, or here it's a collection. We query a collection. And this query queue, we just on snapshot queue, and we will get this lambda called with the query snapshot. So the result of the query will be called on this lambda each time it changes. And then we can do our updates. It's very, very simple to do that. So this is one thing I really like about Firestore, that if you really think about Firestore at the beginning of your design, you can get really offline and real-time for free. Is it really so shiny? Well, there are some limitations. Because we use Firestore for all the syncing, we don't call a get or an update, put, etc. It's difficult to get the monitoring of this syncing, because Firestore is doing it for you. When it works, that's really fine. But when it doesn't work, it's really difficult to understand. And even if it works, we cannot say, for instance, we can say easily the number of people who update something if you do not put a trigger on that to get an update and a log about that. Because you just do your change on your mobile, on the front. So this will go in the logs in your front. But if you want that to get in the logs that you can monitor, you need to do a log on your backend, on the server side. And for that, you will need to make a trigger, for instance, on the changes. So you need to add your own logs, your own traces about everything, where usually you just have to monitor your calls to your server, and you can see the number of calls, the latency, the performance, and so on. Another limitation is security model. Security model is very limited, as I said. So you cannot use any code in your security rules, just very basic functions, but no really coding or business rule. So you need to design your documents accordingly. You need to design your documents so that the whole document is accessible by one person or not. So you cannot have a part of a document accessible and not. This is not possible. So and you need to also to say the document will be accessible for one user or not. So this document design may lead to updates. If you have a requirement on security which changes, you may need to update your documents because of that. So in kind of maintenance, this is something that is you need to think about. This is not too much an issue here because a lot of things are public. But for the design, we intend to make an access for the speakers to have access directly on the mobile app about the ratings or the feedbacks that you give to the speakers. And for that, we need to have the good kind of security, and we need to think about that all the time. There is also limited control over local storage. All we can do is set the size limit of the persistent store that you have, and that's pretty much all. That can be an issue because we cannot clean up a subset of that data. So if you browse the Devoxx Belgium 2023 event, you will get all the data on your local storage. And then when you go on another event, when the event is finished, we could say, okay, we can give some space free, but we cannot decide of that. Firestore is deciding for you. And also, how do you deal with security issues? If at one time you leak something which should not be leaked, if you leak it in a document that has been synchronized, it's synchronized everywhere, and you have no way to make an update on your app to remove that just on the local application. You can remove a document, but then you remove a document on the local and on the server Firestore database. Okay, so this is almost it. Get to the conclusion. So I would say that in conclusion, Firestore is a very powerful tool. It really helps to get the mobile app working in only a few months. Only 2 people work on that, and only 1 developer, actually, because Robin is a UI designer. So it's really nice to have such tool to help to develop very quickly an application which is able to deal with thousands of people using it during a conference without having Frederic losing his mind. Well, he's sick anyway, but during the conference. So this is very helpful to have such a tool. Mobile development with Ionic and Capacitor is very easy. You get the tools to have your updates instantly, and this is very convenient, and you get your app running on the Android and iOS very easily. So this makes a really nice app with only 2 people. Voxxrin project is open source, as I said. It's open to contribution. You've got the GitHub link, github/Voxxrin/Voxxrin3. So you can open pull requests to give, or just issues to give feedback. And also, I would say that deep AI images are, well, this is what deep AI generated when I said that in Firefly. It was funny for me. Thank you for your listening. Do you have any question?
Just one.
Yeah?
Why don't you use the sub-collections for the events, for the days? Under the days, you have a big object with an array.
Oh, yes. So the question is why? I think I'm losing my. No, it's okay. Why are we not using sub-collections to store the details of the schedule of a day? The intent for that, we did some experimentation. Quick experimentation, and we got better performance to load the whole document, everything in one document, because when we access the schedule, we access everything. Actually, we don't we just load everything. So it was the performance was better because anyway we will need to load everything. So it's a kind of design to, we try to have a direct design depending on the usage on the UI directly. Because here the organization of the data is directed by the organization of the UI.
Okay, that's a good answer.
Thank you. Any other question? Yeah?
Yeah, I noticed that you don't have to log in to use the app.
We don't have a login to use the app. So this is by design currently. Actually, there is a login, but it's an anonymous login. Firebase is allowing. So I talked a lot about Firestore, but Firestore is part of the Firebase set of tools. And in Firebase, you can deal with authentication. And here we have only an anonymous authentication. So we have a user ID, so everybody is a user. But if you clear your data and come again, you are a new user. We can convert an anonymous user to a logged-in user. It was a matter of time to deal with that. Actually, at the very beginning of the project, I did a branch. On my side, I did a small version in React, and I did the authentication and the conversion, the way to upgrade to a signed-in user. But we didn't get enough time, and my time was too limited, unfortunately. And so we didn't get enough time to merge that or to take that from that branch. But the branch still exists. So we can get that and really move on about that. Any other question? No. Thank you.